Hello. I'd like you to take a moment to look around you. Chances are that everything you see, from the paint on the wall to your computer screen, is made from materials that originated from oil or natural gas. Of the thousands of substances used to make our houses, cars, electronic devices, clothing, and even food additives, 85% come from oil. This is a non-renewable strategy that contributes to pollution, habitat loss, and climate change. Whichever way you think about that, things have got to change. We can all agree that measures need to be taken to reduce our dependence on these substances by extending the life of existing products and reducing unnecessary consumption. But we don't need to abandon technology. In fact, that's not an option for us. We need technology if we are to provide 8 billion people with clean water, food, shelter, clothing, transport, communications, medicine, and energy, and not only maintain the status quo, but improve lives as well. But we must find alternative processes for generating the starting materials for the products we need, and do all of this as efficiently as possible to make room for the natural world. I believe that the key to achieving this goal lies in biology. Each of the millions of species of bacteria, plants, fungi, and animals on Earth produce hundreds of different chemical substances in order to survive, grow, reproduce, and defend themselves. They do this using simple ingredients like sunlight, water, air, and sugar. They work efficiently and don't produce polluting byproducts. We currently extract many of these chemicals for our own use, things like alcohol, flavorants, dyes, and even medicines. But recently, scientists have done much better than this. By harnessing the power of genetic manipulation, we can copy nature and insert the necessary DNA instructions into other organisms like yeast, algae, or bacteria that grow quickly and produce large quantities of products. These tiny cells are the equivalent of extremely efficient manufacturing facilities. We use them to make the same chemicals that come from oil, and the resulting products are identical. We can even make new materials that would be impossible or very impractical to make using current methods. In my own research group, I'm interested in an enzyme called nitrulase that originates in plants where it produces two protein components. If you just copy the DNA directly, this is all you get. But I wanted to make things not normally found in nature. First, we needed to understand how the enzyme worked at the most fundamental level. For me, this meant the scale of individual atoms, taking biology into the realm of chemistry. But how to achieve this? First, we needed to see features within this delicate biological material, the size of a millionth of the width of a single human hair. We turned to cryogenic electron microscopy, where samples are cooled so rapidly that water doesn't have time to form ice, and collected images using a powerful electron microscope. This resulted in the first visualization of this kind in Africa. What we saw was astonishing. The enzyme made large-scale changes to its overall shape in response to small changes we made in its DNA sequence. We used this information to design a new enzyme that produces a flavorant and preservative of food, as well as other chemicals that can be used to make products like drugs and pesticides. We also found, rather unexpectedly, that our new enzyme removes toxic cyanide waste from the environment, which was a bonus. Since this first result, we have applied these methods to visualize other enzymes, most recently a human protein involved in blood pressure regulation, the results of which could lead to better treatments for heart disease. We have studied vaccine candidates for HIV, potential drug targets from tuberculosis, and of course other nitrulases, which we hope will be used to make even more products in the future. Now we are expanding this approach by working with scientists from all over Southern Africa to use these advanced techniques to solve problems in manufacturing, health, and recycling. Biology has the potential to make our lives sustainable in an economically viable way, and it's important for everyone in the world to have access to this technology to empower them to address their own problems. Ultimately, we want to build a facility for doing this kind of work in Africa, which is the only continent on Earth that lacks these types of microscopes. In conclusion, we need to change the way we think about manufacturing while preserving the natural environment. It's becoming increasingly clear that investing in technology is not a choice, but necessary for our future survival. Thank you for watching.